All right, let's become data detectives. Today, we're going to uncover the secret stories hidden in the relationship between two simple quantities, x and y. It's time to crack the code. So, here's the first puzzle we need to solve. Who's in charge? You see, in any relationship between two numbers, one of them is the leader, the one calling all the shots, and the other one just follows along. Our mission? Figure out how to tell them apart. Okay, first things first, we've got to understand this power dynamic so we can pinpoint exactly who our leader is. So, say hello to our leader, the independent variable. We usually just call it x. Think of x as the cause in a cause and effect story. It's the number of pizza toppings you decide to get, or maybe the hours you put into studying. It's the thing that changes freely, all on its own. And right behind the leader, we have our follower, the dependent variable, or y. And y is the effect. Its value? Well, it depends completely on what x is doing. The total cost of your pizza? That depends on how many toppings you chose. Your test score? Yep, that depends on how long you studied. Okay, this right here, this is basically the ultimate cheat code for figuring this stuff out. Just try plugging your two things into this simple sentence. The blank depends on the blank. So for our pizza example, the price depends on the number of toppings. See, it makes perfect sense. That tells you right away that price is the dependent one and toppings are independent. Seriously, this little sentence is going to be your most powerful detective tool. All right, so now we know how to tell who's leading and who's following. It's time to meet our two main suspects, the two main types of relationships that x and y can have. So, on one hand, we have the additive relationship. This is where you just add a set number to x. You can think of it like getting a little head start. And on the other hand, we've got the multiplicative relationship. Here, x gets multiplied by a number. And the big thing to remember about this one, it always starts at 0. Let's put our first suspect under the microscope, the multiplicative relationship. The pattern looks like this: y equals k times x, where k is just some constant number. But here's the dead giveaway, the smoking gun, if you will. If x is 0, y is always 0. I mean, think about it. If you buy 0 apples, the cost is going to be 0, right? It always starts right at the origin, at 0, 0. Now for suspect number 2, the additive relationship. Its pattern is y equals x plus b, where that b is that head start we talked about. And the big clue here, when x is 0, y is not 0. For example, let's say you're 3 years older than your sister. Well, when your sister's age was 0, your age was already 3. See? It doesn't start at 0. Okay, we know our suspects, but what if all you have is a table of data? How do you figure out which one you're dealing with? Well, it's time to open up our detective's toolkit. Here is a super simple, foolproof process. First, you're going to run the addition test. For every pair of numbers, you just subtract x from y. Easy enough. Then, you run the multiplication test. You divide y by x. And then, you just look at your results. Is the number you get from one of those tests the same every single time? So if y minus x gives you the exact same number every single time, bingo, you've found your culprit. The relationship is additive, and that number that keeps popping up, that's your b, that's your head start. And on the flip side, if y divided by x is the same constant number for every single pair, well, you've got yourself a multiplicative relationship. That constant number is your k. Case closed. Okay, so we've cracked the code, we've identified the relationship. Now it's time for the big reveal. Let's see what this looks like when we graph our findings. Now, before we go any further, you have to remember the golden rule of graphing. The independent variable, that's our cause, it always goes on the horizontal x-axis at the bottom. And the dependent variable, our effect, always goes on the vertical y-axis on the side. You gotta set it up this way to tell the story correctly. And here is the big reveal. And it's kind of surprising. When you plot the points for either an additive or a multiplicative relationship, they both create a perfectly straight line. How cool is that? This means they're both what we call linear relationships. They show a nice, constant rate of change. You know, every good detective learns to spot the common traps. So to wrap this up, I'm going to give you a couple of pro tips to help you avoid the biggest mistakes people make. First off, the biggest trap is mixing up x and y. Just remember this. Time is like the ultimate independent variable. It just keeps going no matter what. So time always goes on the bottom x-axis. And second, don't just assume a relationship is multiplicative because the numbers are getting bigger. You have to do the division test.
If y divided by x isn't a constant number, then it's not a multiplicative relationship. Simple as that.
So there you have it. The secret story of X and Y really just boils down to cause and effect. And now you have the tools to be a real data detective. So the only question left is, what happens now? When you look at the world around you, I don't know, the cost of your data plan, the miles on a road trip, how much your plant grows every day, what relationships are you going to uncover?